So, in the tradition of The Edge, keeping things short, sharp and smart, I would like to dive straight in and introduce you to our first speaker, Matt King. Matt King is Professor of Polar Geodesy at the University of Tasmania. He's also acting head of the School of Geography, Planning and Spatial Sciences and will soon lead a new Australian Centre for Antarctic Science. He has published more than 130 papers in scientific literature, including many in the leading journal Science and Nature. A large part of his research has focused on ice sheet and sea level change, and in 2012 he was part of an international team coordinated by NASA and the European Space Agency that established the first agreed estimates of the contribution of Antarctica and Greenland to sea level. For his research, he's received medals from the Royal Society London and the Australian Academy of Sciences. Please welcome Matt King.
Well, thanks, Ella, and it's great to be here with you tonight to talk about climate science, to begin with at least. And in one regard, you won't be learning anything new tonight. Hopefully you won't leave and shut your screens down straight away. You're not going to learn anything new because climate science is not new. In 1856, an American scientific researcher, inventor, and women's rights campaigner by the name of Eunice Foote had her work presented at one of the most prestigious scientific societies in the world, the American Association for the Advancement of Science. Her paper was, we understand, a world first. In it, she described the effects of the sun's rays on tubes of different gases. She demonstrated that heat from solar radiation was absorbed by carbon dioxide and water vapour, and suggested this effect could be a cause of climate change. Now, Eunice's work disappeared from memory until recent years, but the work of an independent researcher at the same time in the UK, John Tyndall, did not. John Tyndall was looking at the same thing at about the same time, and he devised a simple but elegant experiment to explore the interaction of various gases with solar radiation. He concluded in 1859, thus the atmosphere admits of the entrance of the solar heat, but checks its exit, and the result is a tendency to accumulate heat at the surface of the planet. The atmosphere admits the entrance of heat and checks its exit, and the result is the accumulation of heat at the surface of the planet, 1859. And so while the science has developed further since then, as you'd expect, we've known for about 160 years that the atmosphere is a primary control on the temperature of the planet. It keeps the Earth's temperature at about 15 degrees Celsius instead of minus 18 degrees, as it would be without an atmosphere. Now, it's not even that cold here in Tasmania. And for 160 years, we've known that changing the composition of the atmosphere, notably changing the amount of carbon dioxide in the atmosphere, will lead to a change in Earth's climate. So if the science is that old, why are we still discussing it? Well, we're going to come back to that question in the second part of my talk. But first, we're going to have a brief look at the evidence of climate change. So what do we know? Well, we know that after thousands of years of stable carbon dioxide levels in the atmosphere, that since the Industrial Revolution, the amount of carbon dioxide has increased by about 50%. And we know because of chemical fingerprints in the atmosphere that the change is driven entirely by burning of fossil fuels, that's coal and gas and petrol and things like that, and other human activity. All of the change. In fact, we know that the natural systems, such as the oceans, have absorbed more carbon dioxide than before, meaning that without that role, the atmosphere would have had more carbon dioxide in it than it currently does. At present policy levels, we expect carbon dioxide will peak at about 670 parts per million, approaching triple the background levels of the last 1,000 years when human civilizations prospered. Now, one of the myths one hears is that these changes are tiny and hence can't be important. The increase in carbon dioxide, after all, is only about 140 parts per million, or 0.014% of the atmosphere in absolute terms. To some, that seems ridiculously small to matter. But one thing, that myth ignores the science that we've had for 160 years, showing that small amounts of these gases really do matter. And two, anecdotally, we know that small bits of changes in chemistry can matter. 10 milligrams of my heart medication keep me alive, even though it's only 0.00001% of my body weight. And because carbon dioxide levels have gone up, we expect the Earth to trap more heat. And in 1938, an English steam engineer named Guy Callender first identified a trend in the Earth's land temperatures, and he linked it to rising carbon dioxide levels. Callender hoped it would delay the, quote, return of the deadly glaciers, as he put it. Now, that was quite an understatement, as we'll soon see. Now, when we look at global measurements of Earth's temperature, including those so carefully prepared by the Australian Bureau of Meteorology, we see exactly what Callender began to see. As we see on the right, by 2020, global average temperatures had risen by about 1.1 degrees Celsius since the Industrial Revolution. Most of that rise has happened since the 1960s. And if you were to look at the 10 hottest years in the global temperature record, you would see they all occurred in the last 15 years. The Earth is warming, and I don't think you need to be a scientist to tell it. We continue to emit carbon dioxide and other greenhouse gases as we burn coal and gas and petrol and deforest the land. But the future emissions change will govern the next decades and centuries and beyond of the Earth's climate. Scientists can combine different emission scenarios with an understanding of the physics of the atmosphere and can project how the Earth will warm over under those different scenarios. And we know that, as a result, unless a very dramatic change occurs in human activity in the next decade or two, that Earth will warm by several degrees this century and more beyond that. The land will warm more than the ocean, and extreme temperatures will become more extreme and more frequent than now. For instance, we now expect day temperatures in Western Sydney to go above 50 degrees at times in coming decades. Today's extreme temperatures will become more commonplace, and it's the extreme temperatures that will really bite us. Even with a global average temperature warming of 1.5 degrees, and that's only 0.4 of a degree from now, extreme hot days in regions like Australia will warm up by 3 degrees. Western Sydney could have an extra month of days over 35 degrees by 2090, an extra month of them. And there's global agreement amongst governments, including Australia's, that we must limit warming to that figure of 1.5 degrees if we're to avoid the worst of climate change. As shown on the left, those who are tracking current solid international policy targets say that current policies will limit average warming to 2.9 degrees, optimistically 2.1 degrees. And when you look at the impacts of such climate change, you start to see why concern is rising. Sea levels are already higher than at any time in the last 2,000 years. We all know that when you heat ice, it's going to melt, and the Arctic in particular is warming at twice the average global rate. Almost all the glaciers globally are retreating, and the vast ice sheets of Antarctica and Greenland have begun to wake up in the last 30 years, and their change is now measured in hundreds of billions of tonnes of ice melt per year. And if you sum up the full picture, Earth lost 28 trillion tonnes of ice in the 23 years from 1994. Now, land ice melting drives up sea level, and about 30 centimetres is already locked in for the coming century, but a rise of up to a metre or even beyond is not outside the bounds of possibilities if climate change goes unchecked. Extreme sea levels will increase in frequency, just like air temperature extremes, and by the end of the century, in coastal Australian cities like Brisbane and Hobart and Melbourne, what was a once-in-a-100-year coastal flood will occur between once every month and once every day if we do little about climate change. Now, for Australians who love the coast, that is devastating news. That means shoreline retreat, beach erosion and inundation. It puts at risk $230 billion of Australian infrastructure. That's our homes, our businesses, our roads, our factories, our airports. In many places, those roads and houses were built on the edges of the beach, and so there's nowhere for the beaches to retreat to. And so, in places, a trip to the coast for our children and our grandchildren will look very, very different to the trip to the beach that we had when we were small. And while rich countries like Australia may well adapt to some extent, the poorest of the world will suffer the most from climate change. A UN report from 2016 highlighted that low-income countries are the hardest hit by weather-related disasters, 25 times more in terms of GDP. Those countries are already preconditioned, you see, to make adaptation to disasters very hard indeed. And increased extremes from climate change will only make that harder and bring that inequality higher. As this slide shows, agricultural revenues will likely go up in the future with higher climate change, but productivity will go down as it's harder to do manual work in the heat. Food prices will increase dramatically, disasters will increase, and health will suffer, with the net effect driving tens of millions more people into poverty by 2030, just 9 years from now. In Bangladesh alone, 13 million people could be displaced from their homes and their livelihoods by 2050, just 29 years from now. And our nearest neighbours in the Pacific have vast fractions of their entire national infrastructure, tens to hundreds of metres from the current coastline. Climate change, you see, is not just about us, and it's not just about the distant future. These changes are real, they're dangerous, they're on our doorstep, and humanity is driving them. The experiments of Foote and Tyndall were not politically motivated. Thermometers are not issued by political parties or activist groups. These are real changes, and we're seeing the Earth behave in the way that the physics of the atmosphere and the Earth system would expect. One of the world's most prominent carbon research institutes did research into climate change in the 1980s, and it recognised the impact that it would have on the planet. But the organisation didn't respond to that knowledge in the way that you might expect. Although when I tell you the company's name was Exxon, now part of ExxonMobil, you may understand why. In 1988, Exxon consciously adopted a position that would emphasise the uncertainty of the science. Just as consensus was emerging in the climate science community that humans were driving the climate change we were seeing, Exxon chose to emphasise the uncertainty. And Exxon weren't the only ones. In 1998, a communications expert called James Walker delivered the Global Climate Science Communications Plan. Sounds really promising. He delivered it to the American Petroleum Institute, a peak body involving Exxon, Chevron, and other companies interested in petroleum and coal. The plan again aimed to promote discussion of uncertainty and undermine what was already then abundantly clear. The Guardian newspaper reported that the plan sounded much like a 1960s PR campaign devised by the tobacco industry to delay controls by questioning the science that showed that smoking killed. And some of the people involved in this new plan were in fact veterans of the tobacco industry campaigns. You see, Exxon knew about climate change, the American Petroleum Institute knew, and they acted to sow doubts in the minds of the global public just at a time when the science was coming extraordinarily clear. And they did it because of self-interest. There was a deception. But I think also there was a self-deception. There's no doubt in my mind that many of us wanted to be reassured that we didn't need to change. Our nations didn't need to change, our businesses didn't need to change, we as individuals didn't need to change. We wanted to be unconcerned about climate change. And Pope Francis actually picked up on this theme and said that human selfishness is responsible for climate change. Now, given that statement from the Pope, there's some irony then that Christians in Australia have often led the charge of scepticism or doubt or just plain unconcern about climate change, even though it's long been clear that the world's poorest will be affected the most by it. Now, you may have been invited by a Christian here tonight, and they may well be squirming in their seats right now. Don't worry, they will cope. I personally think there's great theological reasons why Christians shouldn't be the least surprised that the humans are busily heating the planet to extreme levels and deceiving one another in the process. But even if we have the best of intentions, we know that human psychology works against us. We know that given a choice of 1 bag of lollies today and 2 bags next month, most of us will take the 1 bag today. Hazards on the horizon don't seem as big and as threatening as smaller hazards immediately in front of us. And that's, of course, where good policy comes in, because it can recognise those trade-offs and consider the greater good. And especially so when you consider it's not the year-to-year that matters, but the cumulative adding of carbon dioxide to the atmosphere. Smoking 1 cigarette may not have an obvious effect, but 20 years of daily cigarettes will do and will kill you. But I wanted to finish with hope, because there is hope. There are ways to mitigate the effects of climate change, to adapt to it, by better house design, better urban planning. Growing trees in your garden or street can reduce urban temperatures by several degrees. Planting even 1 small tree in the right place can produce a cooling effect of equivalent of 2 air conditioners. Small changes, you see, can make a massive difference in the livability of our cities, our towns, our houses. But to avoid the worst of climate change and its impact on the world's poorest, we have to get emissions down, and we have to get them down to net zero, and very quickly. The change in government in the US will rapidly drive change in global expectations on climate change. China has now pledged to be carbon neutral by 2060. Not nearly enough, but more ambitious than Australia. One can expect future trade deals with Australia to require more dramatic action from Australia on reducing emissions and exiting out of coal and gas as quickly as possible. Now, there has been a massive reduction in the cost of renewables, such that they are now the cheapest mass market energy source. We do still need to crack the energy storage issue, but distributed energy generation of wind and ocean energy, solar energy, pumped hydro, batteries and hydrogen generation may produce a combined solution. In my opinion, we should have had a discussion about nuclear power decades ago, but the timescales of nuclear power approvals and building would be simply too slow, and that has left us as not being an option. Now, the good news is that humanity has tackled big problems before. In 1985, the hole in the ozone layer was discovered, and global action was quickly taken. In the early 1990s, another hole was discovered, this one in terms of retirement savings, one that would have the worst effects decades down the track, just like climate change, and compulsory superannuation contributions were introduced to address it. The destruction in Darwin by Cyclone Tracy resulted in major changes to building codes. And all of those show that we can respond quickly to large crises, even if they're over the horizon or feel remote, and we can act for the benefit of others who follow us. And the winds are changing in society. The Australian Farmers Federation now have a climate change policy. Car manufacturers are abandoning petrol engines. Australia has the highest uptake of rooftop solar in the world, and 2020 broke our previous record by almost 40%. Most of us would like our kids and our grandkids to inherit an environment that was at least as good as the one that we've grown up in. Most of us would like to avoid further burdening the poorest of the world. But the worst of climate change will make life harder for everyone. It will erode our coastlines, it will destroy ecosystems, it will hit economies, the poor will suffer. But happily, there are things we can do now, things we can do individually, things we can do corporately, things that we can do in policy. Solutions exist, and the motivation is there if we consider not just our own interests, but also the interests of others. There is hope, and one of the greatest bits of hope is that you've bothered to join us here tonight. Thank you for your time.